We're back. Here talking about 5.7, which is combining functions. What a great time it is to learn about our Common Core State Standard FBF1.B, which says combine standard function types. Alright, let's skip over this, it's a lot of reading. Okay, so basically when you see things like this, you're going to be possibly very confused and you probably want to quit, but this is really not complicated. If you see f plus g, parentheses x, that just means you're adding f of x plus g of x. Okay, so you have two different functions, f and g. They're called f. One's called f, one's called g because they're two different functions, they're just different names. And when you see f plus g in parentheses, that just means you're taking the two functions and adding them together. Okay, if it's subtraction, you're just subtracting them. So it's f of x subtract g of x. If you see times, then you're multiplying them together. If it's division, then you're just dividing. On this one it says g of x cannot be 0 because if g of x is 0, then you're dividing by 0 and that doesn't work. So that's the only caveat there. But yeah, so don't get confused and overwhelmed when you see this because it's really not complicated. It's not confusing. Okay, so if it's plus, you're just adding them. Subtract, you're subtracting them. If it's multiplication, you multiply them, and if it's a fraction or division, you just divide them. Okay, and I will show you what these look like because you're probably like, what are you talking about? But here, so this says what is the sum, meaning you're adding them. Okay, so you have f of x, which is this one. That's your first function. You have g of x, which is this one, is your second function. Again, it's just f and g because they're two different functions, so they're different names. These are just the names of the functions. And remember, these are like your y values, so they really don't have any meaning. They're just there to give them different names. Okay, it's like your y values. So what are f plus g of x? Okay, let's look at that right now. Don't worry about this for a second. Okay, but what is f plus g of x? That means you're adding these two together. So I'm going to say f plus g of x, not times x, it's just of x. I'm going to add f of x, which is this one. So 5x minus 7 plus negative 2x plus 1. Okay, and this is just simple addition. I can just combine my like terms. So 5x plus negative 2x gives us 3x. And then negative 7 plus 1 gives us negative 6, so 3x minus 6. So I say f plus g of x equals 3x minus 6. Okay, and then the next part says, what is f plus g of negative 3? So what that means is you're plugging this. Negative 3 is going to be your x value. So now I go from this equation here that we just came up with, and I plug negative 3 in for x. So negative 3 goes in for this guy right here. So then we say f plus g of negative 3 equals 3x, and instead of x I'm putting in negative 3, plus 6. 3 times negative 3 is negative 9, plus 6 gives us negative 3. So we say f plus g of negative 3 equals negative 3. Okay, just a coincidence that those are the same number. Okay, that does not always happen. It's just a pure coincidence here. Okay, so not too bad. You're just adding the two functions together and then plugging in a number, which is this one right here. Okay, so let's look at the second one then. Okay, so now we have these exponential functions. So 4 times 3 to the x is f of x, and then g of x is 3 to the x plus 2. What is f subtract g of x? And f minus g of 2. So let's find this one first. So f subtract g of x. So we're going to start with f. So 4 times 3 to the x subtract 3 to the x plus 2. I'm going to put that in parentheses because I'm subtracting all of it. And to get rid of the parentheses, we have to distribute that negative through. So this is really the same as 4 times 3 to the x, subtract 3 to the x, subtract 2. Okay, and then again, you're just combining like terms, and in this case, your like terms are going to be this 3 to the x and then the 4 times 3 to the x. So I have 4 3 to the x's here, subtract, there's only 1 3 to the x here, so that actually gives us 3 times 3 to the x, because it's like 4, this is like the same as 4y minus y, that's just 3y, okay, but in this case it's 4 3 to the x, subtract 1 3 to the x, that's why you get 3 3 to the x's here, and then we saw this minus 2 on the end. Okay, you could probably leave it like that, but if you notice, this 3 and this 3 are now, they have the same base. So this is 3 to the first times 3 to the x. So when they have the same base and they're being multiplied, we can just add the exponents. So we can say this is the same as 3 to the 1 plus x, and then subtract 2. I'm kind of running out of room here. Let me erase this. So you can say 3 to the 1 plus x, or x plus 1, subtract 2. It's going to be what the function is. And then we need to plug in our x value, which is negative 2 in this case. Okay. So then we say f subtract g of 2 is going to be 3 to the 1 plus 2. That's our x value, subtract 2. 3 to the 1 plus 2, that's 3 to the third, that's 27. Subtract 2 is 25. Okay, so if you plug in 2, you should get 25. And that should work if you didn't simplify this also. So if you left it as 3 times 3 to the x minus 2, you should still get 25. Okay, on to the next one. Okay, so I'm going to let you try this one. This one you're adding them together. And if you notice, you have a exponential and a linear here, so really you can't combine those x's. So don't worry about that. But you can combine the constant terms. So go ahead and try this one, and you can pause it, and we'll go over it. So pause in 3, 2, 1, pause. Alrighty, welcome back. So when you're adding these together, I didn't put parentheses around here because the parentheses really, you only need parentheses if you're subtracting because you have to distribute your negative. But you can put parentheses if you want. So I can combine the negative 4 and the positive 8 to get a positive 4 here, but I can't combine these two because one has an exponent with an x and one is just 3 times x, so I can't combine those. So I just leave it like that. So that's going to be f plus g of x. Then, from there I plug in the 3. Okay, so I get 5 to the third plus 3 times 3 plus 4, 125 plus 9 plus 4 gives us 138. So that's what you should have got for that one. Alright, moving on to multiplication, I believe. Multiplying and dividing. Here we go. Okay, so similar type of thing. You're just multiplying the two together. So on this one, we're doing f times g of x. So I do my f of x, which is 2 times 5 to the x, multiplied by 3 times 5 to the x. Okay, and on this, you can multiply the whole numbers together, meaning the ones that don't have exponents. So the 3 and the 2, you can multiply those together to get 6. And then you can combine your 5 to the x's because they have the same base. So this 5 to the x and this 5 to the x. If we add, when you're multiplying, you add the two exponents. So this is going to be the same as 5 to the x plus x. And 5 to the x plus x is just 5 to the 2x. So 6 times 5 to the 2x. Okay, and that's it, yeah. That's basically all you can do on that one. But remember that when you're multiplying powers with the same base, you add the exponents. And x plus x gives us 2x, not x squared. So 5 to the 2x times 6. And then again, don't multiply 6 and 5 because this has an exponent. Can't do that. Not allowed. Okay, then we plug in negative 1. So f times g of negative 1 now. So we get 6 times 5 to the 2 times negative 1, which is going to be 6 times 5 to the negative 2. And then remember, if it's a negative exponent, it becomes a fraction. So the 6 stays on top. 5 to the 2, now positive 2 goes on the bottom, which is 6 over 25. And that is simplified. 6 doesn't go into 25. and they don't have any common factors. So now we're dividing. Now dividing typically is the simplest because there's not a lot of ways you can simplify division problems. But if we want f over g of x, basically all you do is you make a fraction line, you write the f on the top, 4x plus 3, and you write the g on the bottom, 2x minus 7. What I do not want you to do is to say we can take 4 divided by 2. You can't do that because of the plus and the minus. This all has to stay together, and this all has to stay together because it's connected with a plus or a minus. Okay, so you can only start canceling things like, say, if it was 4x times 3 over 2x times 7, then you could cancel them because it's all multiplication on top. But whenever you have a plus or a minus, all of those terms have to stay together. So you can't just cancel out the 4 and the 2. Okay, so this is actually all you can do. And that's as simplified as you can make it because you can't cancel the 4 and the 2, and then nothing really cancels there. So then we just plug in 12. So 4 times 12 plus 3 over 2 times 12 minus 7. That's going to be 48 plus 3 is 51 over 24 minus 7 is 17. And those actually divide, I think. 17 times 3 is 51, I believe. Yeah. So that just comes out to be 3. So that was nice. Alright. And that's division. So most of the time you're just writing it as a fraction and then plugging in a number, whatever it gives you. In this case, 12. Okay. On to the next one. Okay, I will let you try this one. This was a multiplication one. Okay, so see if you can do this. And you can pause this in 3, 2, 1, pause. Alright, so welcome back. When you're multiplying these together, make sure you put them in parentheses. So I did 8x plus 15 in parentheses times 4x in parentheses. And then what I did is I just moved this to the front because we can do that. So 4x times 8x plus 15. And then to solve that, or to simplify it, we are going to want to get rid of the parentheses, so we distribute. When you distribute, this is 4x. There's 2 factors there, so you're multiplying the 4 and the x to everything. So 4 times 8 gives us 32. X times x gives us x squared. Okay, and then 4x times 15, well 4 times 15 is 60, and you should have your x, so 60x. So this is the simplified version here, 32x squared plus 60x, and then we just plug in negative 5. 32 times negative 5 squared plus 60 times negative 5. Negative 5 squared is positive 25, so remember negative times negative is positive, and then I just move that negative 5, that negative to the front, so subtract 60 times 5, which gives us 800 minus 300, which is 500. And yeah, that's it. Next. Okay. Wildlife management, problem number 3. A biologist is studying the deer populations in 2 state parks. She projects the population in Park A in X years will be modeled by the function AX equals 200 plus 25x, and the population in Park B modeled by B of x equals 100 times 1.05 to the x plus 40. What is the function giving the projection for the total in both parks? Okay, so it's saying you want the total in both parks, yeah. So that means you're adding the 2 together. So really what this wants is a plus b of x. So we're just going to add the 2 together. So 200, a is 200 plus 25x plus b, which is 100 times 1.05 to the x plus 40. Okay, and then on these, we can combine the constants, which is the 200 and the 40. The x on this one and this one, we can't combine because one's in the exponent again. So we just combine what we can, and then, yeah, that's all we really can do. So we combine those, and we get 240. Still have the 25x. Still have the 100 times 1.05 to the x. We can't combine this 100 with the other ones because, with the 40 and the 200, because it's being multiplied, not added to everything else. So we just leave it like this. And then it says predict the total in 4 years. So then we plug 4 in for x. So a plus b of 4 equals 240 plus 25 times 4 plus 100 times 1.05 to the 4th. So that's going to be 240 plus 100 plus 100 times 1.05 to the 4th. I don't know what that is. My handy dandy calculator out. 1.05 to the 4th times 100. 121.55. Okay, so we add that together. 240 plus 100 plus 121.55 gives us 461.55. And what is this in? Just in whole numbers, I guess. So about 462 deer in both parks combined. Yeah. So you're just adding them together. And that's essentially the whole idea of this unit, or this section, is just combining different types of functions. 1 second. Come in. Anyway, go ahead and try this one. This one is asking for a difference, so it's a subtraction problem. So see if you can figure this one out. Pause this in 3, 2, 1, pause. Alright, so when I did this, we subtracted. There's a couple more terms in this one, so there are some like terms that you can combine. So again, I put it in parentheses because of subtraction. I distributed here the negative, so then I can combine. So I got 950 times 1.29 to the x, subtract 120x, subtract 500x, plus 600. So these both have x's with them, so we can combine those two. And they're not in the exponent, so they are like terms. So negative 120, subtract 500 gives us negative 620x. But then we can't combine anything else. So this is going to be your simplified function here, the combination of the two. And then we want to know the difference in the populations in 6 years. So we plug in a 6 for all the x's, for those two x's, and I got 1,258 about the difference in 6 years. So city C will have 1,258 more sparrows than city D. Super important information to know. But yeah, so that's how you combine functions. Again, you're just adding or subtracting them, combining like terms, and simplifying. Not too complex. It looks complex, but it's really not. Okay, so try to do your quiz. Do your best. Let me know if you need anything, and I will catch y'all later. Alright, goodbye.